Hello dear students, let's see this question of IIT-JEE 2003. This question states, a ring of radius r having uniformly distributed charge is mounted on a rod suspended by two identical strings. The tension in strings in equilibrium is T naught. Now a vertical magnetic field is switched on and ring is rotated at constant angular velocity omega. Find the maximum omega with which the ring can be rotated if the string can withstand a maximum tension of 3 T naught by 2. So this is the figure before applying the magnetic field. The tension in the string is T naught. This is a ring having a uniformly distributed charge Q. So let me draw the FBD of this situation here for this whole rod plus this ring mass system. So suppose the rod plus this ring has a mass M. So that's weight would be mg, and tension in either string is T naught, and there is no rotation, everything is in equilibrium. So simply we can write the net force is 0. It means 2T naught is equal to mg. So 2T naught is equal to mg means T naught is equal to mg by 2. That is the first thing that we've got. Now we switch on this magnetic field. So what will be the effect of this magnetic field? This is a charge and it is the ring is also rotated. So effect of this ring being rotated would be a current will come, charge, assuming charge positive in the direction of current. So this now becomes a current carrying wire. Suppose now it has a current I. So current in this ring will become I is equal to Q by T, and T is 2 pi by omega. So we will have a current Q omega by 2 pi in the ring. And now what will be the effect of this current carrying wire being placed in a uniform magnetic field? This is a current carrying loop. So current carrying loop placed in a uniform magnetic field will experience a torque. And before the torque, we will find the magnetic moment of this current carrying loop. So magnetic moment of the current carrying loop, let me write that mu, and mu is equal to IA. The area vector will be in the direction of circulation, or just circulate your right hand fingers in the direction of current, thumb will give the direction of the area vector. In the direction of area vector there is m vector. So we will have a magnetic moment vector in this direction. So this is the magnetic moment vector, and the magnitude of this magnetic moment would be I into area. I am assuming this radius to be r. So this magnetic moment will be I into pi r square. So let me just put the value of I. So that would become Q omega r square divided by 2. Because that pi and pi will get cancelled. That is my equation 3. And now this magnetic moment is there. It is placed in this upward direction magnetic field like this. The magnetic field is in this direction and mu is in this direction. So torque is mu cross B. So mu cross B, the torque will be in the outward direction like this. So direction of torque would be along this direction. If I can draw the torque vector, so torque vector will be along this direction like that, and that will always be along this direction because this mu is always in this direction and B is always in this direction. So mu cross B will be in this direction, and the magnitude of that torque would be because angle between mu and B is 90 degree, so that will be simply mu into B, and mu into B would be how much? Q omega B r square by 2. That is equation 4. And because of this torque is along this direction, so this torque will try to rotate this whole system like this. So this will try to rotate if there is nothing, if I consider only the effect of this torque. So if that is the rod, so that, and the torque is along this direction, and this is the rod, so it will try to make it rotate like this, So now the tension on these two string will have to differ, because right now these tension were not providing any torque, because this separation is same. So to counterbalance this torque, these tension must differ, so that their torque, the torque due to these tension should be like that, and torque due to magnetic field is like that. So they counterbalance the torque due to the magnetic field, so that system is still in the equilibrium. So let me assume that now these tensions have become T1 and T2. Obviously this tension will be more, but it will anyway come with the equations, and the weight is mg. So in the new setup, the equations have become T1 plus T2 is equal to mg, and mg was 2T0. So now T1 plus T2 is 2T0, that is my equation 5. And now I want to apply torque about this point, center of mass. So torque due to this tension T1 is, this separation is d, so this separation is d by 2. So that is a T1 d by 2, and because of this will be this T1 d by 2 will be like that, and this T2 d by 2 will be like that. So because of these two, overall torque about the center of mass would be T1 minus T2 into d by 2, and this overall torque is like that, and this torque, the magnitude of these two torque will be equal to this, so that overall torque is 0, and that should equal to be tau. So I can write now T1 minus T2 is equal to 2 tau by d, and here is tau, so that would become q omega b r square by d, that is my 6th equation. So we can solve these two equations to get T1 and T2, and it is clear that T1 is more than T2. So the effect of magnetic field will be this tension on this string, which was earlier T0, here was also T0, but this side tension will increase and this side tension will decrease. So the reason for this is B and omega. If there was only B but there was no omega, so there will not be any effect. So but these string can withstand a maximum tension of 3T0 by 2. So what will be the maximum omega? For that I will solve equation 5 and 6 to get 2T1. I will just add them. So 2T1 will be 2T0 plus q omega b r square d. So T1 from here will become, dividing this equation by 2, T0 plus q omega r square b r square by d by 2d, we are dividing by 2, and maximum value of T1 means the maximum value of tension either string is 3T0 by 2, and that will be maximum when this omega is maximum. So I can write this 3T0 by 2 plus is equal to T0 is plus q b r square by 2d into omega max. So that will become T0 by 2 is equal to q b r square by 2d omega max. So finally my omega max comes out to be q b r square by d, and that is our final answer. Thank you.